Welcome to this new tutorial. Now we will do the rigging of the Ender Dragon. But first, I will fix the width of the vertebrae. We need them thinner. We select one of these vertebrae and we change to edit mode, with Tab key. With Control Tab key, we can select faces, and we select one of the faces of the vertebra. Press Ctrl plus key, until all faces of the vertebra have been selected. Finally, we can scale it in the x-axis, 0.5, so we will get the half of the width. We have to do this in every vertebra, one by one, in the neck. In edit mode, select all faces of the vertebra, and scale it 0.5 units in the x-axis. We did the ears of the Ender Dragon using the mirror modifier, so, we just need to change the scale of one of the ears, and the other one will be scaled automatically. And the other modifier we used in the other vertebrae was the array modifier. Just changing one of the vertebrae, the rest will be automatically scaled. This is one of the advantages of using modifiers. Now we have got a perfect modeling of the Ender Dragon. Let's go with the rigging. We can start adding the base bone in the bottom of the body. Remember that if you add a bone, or any other element, it will appear where the cursor is located. But we want our first bone in the bottom, here. For that, select the body, and in edit mode, select that face. By pressing Shift S key, we will snap the cursor to that selected face. Now we can add a single bone with Alt A key, in the armature menu. Rotate it in the x-axis 90 degrees. If we change to edit mode, we can move the top of the bone to the other face of the body. If we select the center of the bone, we will select all the bone, and now we can move it in the Z-axis. Now, select the top of the bone. By pressing the number 7 key, we will see the top view. We extrude a new bone, with E key, and if we press Y key, it will move in that axis. We can also type the value, -1.3. Now, the bone of the head. We extrude with E key, and type 2. We can move the top of the head bone, in the center of the mouth. Now let's do the bones of the mouth. First, we can do a little bone that goes to the center of the upper mouth, and then we will extrude the upper mouth bone. And then, we will do the same with the lower mouth. We can remove these little bones. They are useless. Now, the mouth has an offset connection with the bone of the head. Let's do the bones of the tail. We select the sphere of the base bone, and we snap the cursor to that selected sphere. Now we extrude in the y-axis a new bone. Extrude every bone for each cube of the tail. Now, the bones of the wings. Select the upper sphere of the base bone. We can do first the left wing, for example. But then, we have to do the same in the right wing. We can do it easier. Select the upper sphere of the base bone. In Armature Options, on the left side menu, we can activate the X-axis mirror. It works just in X-axis, not like the mirror modifier in which we could any axis. But if we extrude a bone, the mirror bone won't appear. That's because we must do first an extrusion with Shift-E key, not E key. By pressing Shift-E key, we've got the mirror of the extruded bone. We will move the top of the bone to the base of the wing. Now, we can extrude a new bone with E key. Not necessary Shift-E key again. That is just needed in the first extrusion. We move that bone in the X-axis, 7 units. Again, E key, X key, type 7, and enter. When you create bones with X-axis mirror, if you see the name of the bones here, you can check that the bones of the left have the letter L, and the right ones have the same name, but with the letter I. We will do the same with the legs. Select the upper sphere of the base bone, and extrude a bone with Shift-E key, to get the mirror bone in the other side. The other bones are extruded with E key. The bones of the foot are extruded in the y-axis, -1.5. We can move it a little, if we want. For the rear legs, we select the base of the main bone, and extrude it with Shift-E key. We move it to the top of the leg. Then, we extrude with E key in the Z-axis, -4 units. E key, Z key, -4, enter. E key, Y key, -2, enter. We have finished the armature of the Ender Dragon. Cool! It has a lot more bones than the snow golem. Now, We have to join each part of the body to its respective bone. First, we can join this head to the head bone. But when we move the bone of the head, the ears will be static. We can join first the ears to the head. First, we apply the mirror modifier of the ears. Then, select ears and head by holding Shift key, and finally, join them with Ctrl-J key. Now we have a single component that we can join to the bone of the head. Select the head, and by holding Shift key, select the bone. You must be in pose mode for the armature, so you can select the bone. If not, you will select the whole armature. Now, press Ctrl-P key, and set parent to bone. If you move the bone in pose mode, the head will move as well. That's what we will do with every cube. Select the first cube of the neck, and by holding down Shift key, select the first bone of the neck. Then, press Ctrl-P and set parent to bone. If I now move this bone in pose mode, all the cubes parented to the bones will move as well. The move remains static because we haven't joined it yet. Select the cubes of the nose and the cube of the upper mouth, and join them with Ctrl-J. That joining object will be joined to the upper mouth bone. And we will parent the lower mouth. Great! All the head is rigged now. We can check it a little. Now the body. Apply the array modifier for the 3 vertebrae. Then join them to the body big cube, with Ctrl-J key. This big object will be joined to this big bone, with Ctrl-P, and setting parent to bone. Let's do the wings now. If we select this part of the left wing, the same part in the right wing will be selected, so we need to apply the mirror modifier. But now we must separate these parts. Select the left part of the wing in edit mode, and by using P key, we choose separate selection. That part of the wing has to be joined to the long cube, so, we need to do the same. Apply mirror, and in edit mode, select that part and press P key to separate selection. When the 2 parts are separated from the rest, we select both parts and we join them with Ctrl-J key. Finally, we join that part of the wing to the bone, using Ctrl-P key and set parent to selection. Ups. I joined them with the bone in object mode. If I do that, the wing won't join the bone, because I have selected the whole armature. I have to join the wing with the bone in pose mode, so I can select the single bone. Now it's okay. Go ahead with the next part of the wing. We have to do the same again. We apply the modifier, and separate the object. Now I join that separated part of the wing with the long cube. Ups. I joined the wing with the long cube, but the long cube wasn't separated from the right long cube. Let's fix this. we apply the mirror modifier. In edit mode, we separate the long cubes. The long cube has been separated, but the wing still remains joined to the left long cube, so that we have to separate the wing. Select it in edit mode, and press P key. Now the wing and long cube are separated objects. We can join them. We did it! Now the right wing. That part is easier, because the objects have been separated. We only have to join the wing with the long cube, with Ctrl J key, and then, set parent to the bone, with Ctrl P key. Finally, the last part. For the tail, we have to apply the array modifier, and separate any cube. In edit mode, we select a face of the vertebra and a face of the cube, and press Ctrl plus key until all faces be selected. Then, by pressing P key, we separate them from the rest of the tail. We will select in edit mode any cube and its vertebra, and we will separate using the same method. When each cube is separated from the rest, we can set parent to the respective bone in pose mode, by pressing Ctrl P key. All works good. Let's finish with the legs. Legs are easy to do, because every part is separated and there's no modifier applied. We just need to set parent each cube with the respective bone. All seems to work good. We've finished the skinning of the model. But we need to fix some things. For example, if you move the bone of the body, you can see that the rear legs and tail are not correctly attached. We will parent this bone, in edit mode, to the body bone. Select the rear leg bone first, and then, the body bone, and with Ctrl P, we will parent the first one. Remember that you have to parent this with keep offset. If you use the connected one, the first bone will move to the top of the second bone. Use the keep offset in this case. The other leg have been parented as well, because we are working with X-axis mirror activated. As you can see, both legs are parented to the body bone. Just the tail left. Select the first bone of the tail, in edit mode, and then, by holding down Shift key, select the body bone, and press Ctrl P key. We will use keep offset again. We have the entire armature connected. We could make a pose for the Ender Dragon now, but we will have to move every single bone. One by one. One after the other. I have to move this bone of the tail. And then this one. 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 Oh man, this is exhausting. We have to make it easier, or we will die creating our first animation. If you want to reset the initial position of the bones, press Alt-R, to reset all rotations. If you have moved or scaled the bones as well, you can press Alt-G to reset location, and Alt-S to reset scaling. We can start with the tail. You can rotate this bone by yourself, or, better than that, you can copy the rotation of the next bone. How can we do that? In pose mode, there is an icon called Bone Constraints. We will add a constraint. In the constraint menu, we are going to choose the copy rotation 1. Now we will copy the rotation of this bone. If you select this bone, you can see the name of it here. It is called bone.019. We come back to the last bone, in the copy rotation constraint, and in the target menu, we will select the armature. Now appears a bone menu, and there, we will select the 19th bone. The last bone will copy the rotation of the 19th bone. Activate the offset. If we rotate now the penultimate bone, for example 30 degrees, the last bone will rotate 30 degrees. We can do the same with the penultimate bone. We will copy the rotation of the next bone, and so on. Add a copy rotation constraint, and as target, select armature and then bone 18th. Activate offset. We can see how the penultimate bone is copying the rotation, and the last bone is copying the rotation of the penultimate one. We can realize that normal bones are blue, but the bones with constraints are green. We can continue adding copy rotation constraints in the next bones. we have finished. Let's see what occurs now. If we rotate the first bone, the last bones are rotating too much. That's because if you rotate a bone 10 degrees for example, the next bone will rotate with the first bone 10 degrees, but it will copy that rotation and will rotate another 10 degrees, so it will rotate 20 degrees in total. And the next bone will rotate 20 degrees, plus another 20 degrees of the copy rotation, making 40 degrees. Then, the value will be increasing a lot in each bone. Also, if you rotate the body bone, the tail rotates, because the first bone rotates with the body, and the next bone of the tail copy that rotation, and the next bone copy the rotation of the last bone, and so on. If you don't want it to happen, you have to copy rotations in the local space, not in the world space. Let's change them to local space. Now we can see that the tail doesn't rotate with the body in the world space, because the bones of the tail haven't been locally rotated. And if we move the first bone of the tail, every bone of the tail will rotate exactly the value of the previous bone, without increasing values in the world space. Now, let's see what happens if we uncheck the offset of one of the bones. That bone takes the degrees of the previous bone, but doesn't rotate with the chain. We can decrease the influence of that bone. Now it looks much better. You can see that just rotating only one single bone, all the entire tail is moved. Let's go with the head. We are going to learn now about inverse kinematics. If you select the head bone in pose mode, and grab it, it cannot move. Just rotating. And when it rotates, it moves the next bones, it means, the bones of the mouth. But you never can move previous bones. With the inverse kinematics constraint, we can move the previous bones. Select inverse kinematics in the constraint menu. Initially, you can move all previous bones, from the bone with the IK constraint, to the first initial bone, in the chain length. You can select how many bones do you want moved by the constraint. If the chain length is 1, the chain will go from the top of the bone, to the base of the same bone. If we change the chain length to 2, the chain will end in the base of the next bone. We can increase the length of the chain, to the base of the neck. What will happen now, if we move the bone of the head? Look! We can move the bone of the head. And the bones of the neck are adopting a nice pose. Now, with this easy way, we can move the head and all the neck by moving just a single bone. We can do something like that with the legs. If not, we have to move every bone of the leg to make a pose. We can create an inverse kinematics constraint from the foot to the leg. Let's see what happens. Add an IK constraint and change the chain length to 3. But if we move the foot bone, It does a weird pose. Remove the constraint. In edit mode, we can create a new bone in the base of the foot bone. Extrude with E key. Another bone will be created automatically in the other foot. This bone will be the one with the inverse kinematics constraint. Add it. If we move that bone, the leg will adopt a better pose. We have to add the IK constraint to the other foot bone. Now, by using just one bone, we can move all the leg better. Finally, the rear legs. In edit mode we create a bone in the y-axis, and add the IK constraint, with a chain length of 3. We will finish the rigging with the wings. We need a constraint in the wings, because if you rotate this bone, you can see that the wings looks like it's broken. If you rotate it in the Z-axis, it looks bad. If you rotate it in the X-axis, it looks bad as well. You only can rotate it in the Y-axis. You might say that you want the rotation just in the Y-axis. But if you rotate this bone, now, the Y-axis is not looking at the right direction of the wing, because these are global directions in the world space. If we rotate now in the Y-axis, the wing looks broken. And with a Z and X-axis looks bad, as well. If we change these axes to local space, now we can see they are different. In the local space, the axis pointing in the direction that we want, is the Z-axis, the blue one. If we rotate again the base of the wing, and then, we select the second bone of the wing, we can check that the blue axis is still pointing in the right direction. Then, add a constraint, and select Limit Rotation. We will limit the rotation just in the Z-axis, so we will activate the X and Y limits. We have to change it to local space. If we rotate in a random direction, the wing will rotate just in its Z-axis in the local space. Wherever you rotate the wing, it always looks nice. Now it doesn't look broken. Let's do the same with the other wing. Add a limit rotation constraint, activate the X and Y axis, and finally change it to local space. Cool! All works totally great. Now, We can create a pose for the Ender Dragon, simply by moving and rotating a few bones. This looks awesome, really. Perfect. The rigging has been a success. I hope you have enjoyed this tutorial. See you in the next video tutorial, in which we will create the idle, walk, attack and die animations. Bye.